And welcome everybody to the Daily Space Weather. Today we'll be talking about how the SDO has gone far left, along with so many other things, some sunspot analysis, and some disturbing climate lunacy here at the Smash News Network, least busted name in news. And whoops, we're looking at a 48-hour SDO video here. And here you can see at the end of the video, the SDO turns far left. So those last couple frames there are, for some reason, the SDO is not pointed at the center of the solar disk anymore, as all of our institutions collapse before our very eyes. Here's a Soho movie featuring the magnetogram. And what we're looking at is Sunspot 2018, Sunspot 2820, and Sunspot 2821, this area down here. And they've been basically stable over the past 24 hours here. No major changes. Here's the intensity gram. You can see there was a little bit of evolution going on, nothing really particularly noteworthy, although that sunspot group was noteworthy, one of the larger we've seen during cycle 25. Here's some more imagery from SDO, 193 angstroms as well as 171 angstroms, and the SDO colorized magnetogram as well. Yeah, it's pretty weird. Pretty weird, folks. Next, a chart of the solar system. So here's what's going on in your local heliosphere. There's where things will be in a week. And we're expecting a coronal mass ejection strike here in about a day, sometime tomorrow, probably about midday universal time tomorrow. A coronal mass ejection likely to strike the geospace, according to me and apparently nobody else. Here's also a star chart for you. I've faced mine to the south. I'm using in-the-sky.org. And if you've got clear skies and you're up before dawn, you may see the moon and Saturn and Jupiter out there near the ecliptic. The 10.7 centimeter radial flux now at only 78 solar flux units. Here's the 1-year chart of the radial flux, this black line. Red line is sunspot number. And we don't see any alerts here from NOAA. I'm expecting this time period right in here to see some sort of geomagnetic unrest. Maybe a KP of 4. Maybe a KP of 5. I don't know how the coronal mass ejections weren't noticed or documented by anybody else, but let's move into the realm of earthquakes. So our regular viewers may be well aware that we cover earthquakes on the regs. And here at the Smash News Network, we're well aware that the mechanism behind things like earthquakes and volcanoes is not understood at all. One of the possible explanations for earthquakes is volume reduction. So when you put olivine under great pressure, this hexagonal structured crystal, gets compressed to form a different material known as spinel, a cube-shaped and more dense crystal. And what that does is that creates empty space somewhere deep down in the lithosphere, possibly suggesting that phase transitions from olivine to spinel are responsible for some deep earthquake phenomenon. Perhaps check out this article. It's on phys.org's Earth section. This one does not look like a sharticle at all. Volume collapse instabilities in deep earthquakes, a shear source nucleated and driven by pressure, in the Journal of Mechanics and Physics of Solids. So I'll just let the article scroll here. Going from olivine to denser spinel leads to reductions in volume of rock as atoms move closer to each other under great pressure. This can be called, quote, volume collapse, end quote. This volume collapse and the associated, quote, transformational faulting, end quote, has been considered the predominant cause for deep focus earthquakes. However, until now, there was no model based on volume collapse that predicted the shear distortional seismic waves that actually arrive at Earth's surface during deep focus earthquakes. For this reason, other models were also considered, and the state of affairs remained stagnant. Markinskoff has now solved this mystery using fundamental mathematics, physics, and mechanics by discovering instabilities that occur at very high pressures. One instability concerns the shape of the expanding region of transforming rock, and the other instability concerns its growth. Phase transition from olivine to spinel to grow large. These transforming regions with large densification will assume a flattened, quote, pancake-like, end quote, shape that minimizes the energy required for the densified region to propagate in the untransformed median as it grows large. So perhaps an explanation, volume reduction, perhaps going on in places like the upper mantle to explain earthquake propagation, the transition from olivine to spinel, a more dense crystal with a cubical lattice structure as opposed to a hexagonal lattice structure. Is that what's causing deep quakes? Let's check out the most recent quakes. By the way, we saw one off the coast of Oregon at a 4.4 magnitude. No quakes over a 6 magnitude, although some in the 5 range. And we're just scrolling up the list here. And here's one of note. That one located at New Zealand, a 4.6 magnitude at 157 kilometers. Was there some olivine phase transitioning into spinel underneath the ground at New Zealand? Perhaps was empty space created as smaller crystals created voids which caused the land to settle. I think the largest of the past 24 in terms of earthquakes was this 5.7 at Argentina. It was at depth at over 136 kilometers. Here's a deep quake at the Mariana Islands. Also, Afghanistan saw a deep 4.1 magnitude quake. Actually, the largest quake of the past 24 was this 5.9 in the Kermadec Trench. Some aftershocks from that as well. And moving on to volcanoes. If you're wondering what's erupting, so am I. Here's the list as reported by Volcano Discovery's Volcanoes Today page. Suwanosejima exploded, produced a volcanic ash cloud of unknown size. Semeru, on the Indonesian isle of East Java, produced a 14,000-foot ash plume. Fuego in Guatemala exploded. 17,000-foot ash plume there. Volcanic ash not observed in satellite imagery of Sangay in Ecuador. Don't square dance the caldera. Don't tightrope the caldera. Revenador exploding. Flight level 140. That Ecuadorian volcano producing a 14,000-foot ash plume. And Sabancaya in Peru exploding. Sporadic emissions are enough to produce a 25,000-foot ash plume. A reminder, do not pole vault the caldera. Now, while most of our viewers are not stupid, we would invite our viewers, who are smart and brilliant and informed, to check out our merch, where you can inform stupid people to not pole vault the caldera. If you'd like to find our merch shops, check out smashomash.com. You can find our social media there. Our merch shop is, one of the merch shops at least, is SmAsho merch. There's also a SmAsho store and a Smash store. You can check those out yourself if you're in the market for some gear. And if you click on SmAsho merch, you'll find this, our red bubble shop. And one of the designs there is today's featured product, the Do Not Pole Vault the Caldera Active T-shirt. So this is 100% polyester, folks. And this is going to wick moisture, the way a cycling jersey would. So it's quick, dry, breathable performance for the gym, trail, or wherever. It's got a stretchy fabric made of 100% polyester, which will probably increase its durability as well. A reminder to all your friends and foes to not pole vault the caldera. Let's take a look at the solar flaring of the past 3 days here. No major solar flares here, not even anything in the C-class range over the past 3 days. No proton strikes. And we forecasted no proton strikes despite expecting a coronal mass ejection strike yesterday. I'm not sure if I've seen any such thing. Maybe we're a little bit too early on the forecast, but anyway, there's the proton flux over the past 3 days. No proton events. GOES magnetometer over the past 3 days. You can see pretty high highs and high lows. Actually, this reading isn't really that high. 107 nanotesla isn't a particularly high magnetometer reading, but in any case, there's the data. Let's look at more magnetic data. The top view ecliptic plane field plot, part of the National Sunspot Observatory. And keep in mind this data is nearly an hour old at the time we made the video. Earth is solidly in the North Pole current sheet shown here in green. No changes coming anytime soon. Keep in mind the magnetic environment can change with no warning. Here's a line of sight imagery of the same data as cycle 25 progresses at a very slow rate. Here's a line of sight coronal hole plot. There is a North Pole coronal hole rotating into the Earth-facing zone here. We can expect a coronal hole wind stream from that in about 3 days. And next, the KP index, currently at 2, geomagnetic quiet conditions. Next, the real-time solar wind. Pretty uneventful here over the past 24 hours. Current conditions are about 5.4 protons per cubic centimeter. Solar wind speed only 332 kilometers per second. So back to solar minimum conditions there, folks. A very weak and fairly diffuse, a slow and fairly diffuse solar wind. Here's the magnetohydrodynamic pressure in nanopascals over the past 4 hours. It's today's geospace magnetosphere movie. We'll also show you the ground magnetic perturbations as the magnetic environment coverage continues. Geospace looking pretty weak right now. Here is the ground magnetic perturbation map. We show it daily due to the fact that there's a polar excursion going on. Do you have a theory as to what will happen with the polar excursion? Will the poles reunify? Will they continue to shift? What is your expectation as to what will happen with the geomagnetic excursion that we're currently living through? If you weren't aware, the Earth has 2 north poles, one someplace over Canada and one someplace over Siberia. The net North Pole is someplace around here, and the South Pole is someplace south of Australia, thousands of miles from the geographic South Pole. Anyway, that's 4 hours of data, Geospace Delta B. And since we're moving into the realm of our cosmology segment, let's welcome our Twitch viewers. Welcome, Twitch viewers. Before we do our cosmology segment, some quick notes here. The Smash News Network likes to stream live to twitch.tv/SmashoMash. Thanks to our followers over there. We also stream regularly to YouTube. Thanks to our new subscribers over on YouTube. If you're new to the channel, please press like and subscribe and share the content on your social media, as let's just say the algorithms are not friendly. Thanks to our new subscribers over at BitChute as well, bitchute.com/smashamash. Today's cosmology segment starts out with something totally non-random. It's Galaxy NGC 247. So let's zoom in to Galaxy NGC 247, located at about 11.1 million light years. This particular galaxy has an ultra-bright X-ray source in it. And you can find an article today about that. This is, by the way, the Pan-STARRS view. Here is NGC 247 in X-ray. Let's actually look at it on the XMM Newton, as I know that was involved in the study. I'm guessing probably the ultra-luminous X-ray source is right here, or it might be this. And let's go back to Pan-STARRS. Great high-resolution image of Galaxy NGC 247, part of the new general catalog. So here's the article about this. This is on phys.org's Astronomy and Space section. The quasi-periodic dipping associated with the ultra-luminous X-ray source in that galaxy. Now, we're not exactly sure what's causing it. It could be a warp in the toroidal disk surrounding the galactic nucleus, or it could be some sort of a precessional wobble thing. We're not exactly sure, as sometimes we're not sure the orientation of these objects that we're viewing. The dips can either be caused by occultation of the central X-ray source by an optically thick structure, such as warping of the accretion disk, or from obscuration by a wind launched from the accretion disk, or both. And just bear with me one moment here, folks. Anyway, this perhaps does warrant further study. NGC 247 ULX1. So is it caused because of the precessional wobble? Because we're looking at the pole? Or is it caused by some sort of variations in the accretion disk surrounding that ultraluminous X-ray source? If you have a theory, leave it in the comments. Or perhaps just check out the article here on phys.org's Astronomy and Space section. Today's astronomy photo of the day is Earth. And this particular photo here was taken in 1972 by the crew of Apollo 17 as they returned from the moon. As the International Space Station is way too close to the Earth to get a photo like this, but people returning from the moon are distant enough to get a photo like this. So this one was from December 17th, 1972. And actually, the last picture of Earth from this planetary perspective taken by humans. The astronomy photo of the day you can find yourself at apod.nasa.gov. And that's today's cosmology segment. See you later, Twitch. We'll bring you back for the meteorology segment. Next at the Smash News Network, least busted name in news, we're going to talk about electron flux, which is in a more moderate range here. Here's the one-year chart as reported by Solon.info. Here's a 3-day chart. You can see just toying with warning levels. I wouldn't be surprised to see us go into warning levels here, as we just saw a fairly lengthy coronal hole wind stream just end. So I would forecast seeing warning levels return here today. Let's see what the forecast model says. Well, first, charging hazards, we don't see any. And the forecast model disagrees with me. My forecast is for up here. NOAA's forecast is for down here. It's the green box. And join us for tomorrow's video to figure out if I was right or not. Here's a diagram of the Van Allen belts. We show it daily. Distances are in miles. Here's the total electron content forecast. This is showing you the electron density between your potential handset and GPS satellite And that communication line, when going through large pools of electrons, gets distorted. GPS errors. The closer to red you are, the more significant the GPS errors will be. And if you're seeing like an orange blob over your location on the planet, your GPS error could be like 1,000 miles. Here's another diagram of the atmosphere. We show it daily to show where the F layer is. The F ionosphere layer located at about 300 kilometers. Here's a visualization of that. And the ionosphere looking a little bit anomalous here. We're seeing some sort of extended regions of low frequency regions here at nighttime, and fairly low frequency daytime regions as well. Not as weak as some of the ionospheres that we saw during the most recent solar minimum, which ended in November of 2019. Here's the latest image coming from 9:30 Universal Time. Still looking a little bit low frequency on the nighttime portion of the planet. And now we've moved into the realm of meteorology. So let's welcome back Twitch. And thanks for leaving a comment, John. Hope you're doing well. John says, Grand Rising, the best fact-filled channel on the planet that is energized by the Logos. Thank you. Here are the jet streams of the eastern world. Here are the surface winds. And we see some strong winds here around the coast of Antarctica. How about the surface winds of the western world? There are those. Some strong winds off the southwest coast of South America as well. And here are the 250 hectopascal winds, which elicit the location of the jet streams. And you can see they are all over the place once again. We see S-shaped bends. We see the jet stream blowing north to south. We see it blowing south to north. It's quite chaotic. It's meridional jet stream flow at its finest. And we've got a long band of lightning across a large portion of the U.S. Very active regions here. Some severe storms, mainly across Arkansas right now, stretching all the way from practically from Dallas to Louisville here. And it's calmed down a little bit while we're making the video, but there you can see some thunder rolling in. Hey, Little Rock. Hey, Jonesboro. There's thunder rolling in. I use lightningmaps.org when I hear thunder. And we'll put up a little forecast for this here in a moment. First, let's talk about this insanity. I'll read a quote. More than 11,000 scientists from 153 countries have come together to warn that if we continue with business as usual, the result will be untold human suffering from climate change, Ripple said. We have listed 6 areas, including, get this, curbing population growth in the context of social justice as a framework for action. Curbing population growth in the context of social justice as a framework for action. Now, does that sound utterly insane to you? Yeah, it sounds utterly insane to me, too. And by the way, the planet could probably support 10 billion people if resources were appropriately allocated. The problem on planet Earth is the allocation of resources, not the inability to support many, many more people in the population. It's nonsense that the planet can't support the current number of people that it has, and the anti-humanist agenda is pretty shocking and ridiculous. So here's a sharticle from phys.org's Earth section, which, by the way, this phys.org Earth section is rife with sharticles. We even have a video citing how full of sharticles. In fact, the phys.org Earth section prompted us to make a video called Terms Defined, the Sharticle, because they have so many sharticles. Socially just population policies can mitigate climate change and advance global equity. That is straight up nuts. What a pile of nonsense. What a surprise that it came out of the left coast from Oregon State University. What a pile of nonsense. Satellites show world's glaciers melting faster than ever as the disinformation campaign continues. Now, I don't know if you're aware, but CNN has stated that they're going to rebrand themselves from the COVIDiocy Net News Network to the Climate Nonsense Network. And this is cherry-picked data at its finest, folks, as we saw historic snowfall totals in the Northern Hemisphere for the last 4 winters consecutively. That's 2017 to 2018, 2018 to 2019, 2019 and 2020, and 2020 to 21. We saw record snowfall, 2 standard deviations above normal in terms of snow mass balance, not including mountains. Lots of snowfalls in mountains. Glaciers, are they really melting, folks? We've shown time and time again that Greenland has 5 meters of snow from coast to coast. And this looks like this doesn't pass the smell test to me. Continuing on, here is the GFS forecast for rain. We're going to advance this to show folks how these systems are anticipated to move by the GFS forecast. Pay attention to the time and date stamps up there. I'm just rocking it back and forth a couple days here into Saturday. And that's from tropicaltidbits.com. Here are the current pressure cell situations. And I would like to take a moment to invite our viewers to visualize this in a different way. So if you're not familiar with atmospheric physics, think of it like this. Imagine if this whole area was a kiddie pool full of shallow water, and you pushed your hand on one of these high pressure zones, right? When you push your hand down, you create a high pressure zone in that part of the water. And what does this water do in order to reach equilibrium? What it does is it creates low pressure zones around here to equalize the pressure. This is the thing that's happening in the atmosphere, folks. The main input in the atmosphere is high pressure zones. And I understand that everybody's interested in low pressure zones as they're associated with storms and precipitation. But the understanding of the anticyclones, such as this one up here right at the North Pole, the input of high pressure zones and anticyclones seems to be vastly misunderstood, and I'll just leave it there. Understand high pressure as if you push down in the atmosphere surrounding that area needs to be low pressure in order to reach equilibrium. That's all I'll say about that. I'm just going to advance this into tomorrow. Here is the GFS forecast for pressure at 12 noon Eastern Daylight Time tomorrow. And if you're new here and wondering where we're located, SMASH staff and I are located right about there in Lehigh Valley, Pennsylvania, something like 14 miles west of New Jersey. Here's a U.S. Doppler radar map, and you can see those heavy storms. And they're actually stretching all the way from just north of me all the way down to southern Texas. About a 1,700-mile long arm of storms there. Let's check it out in the cloud layer. There's what's going on in the cloud layer. Here's the water vapor map. That should give you some more insight into the weather. So a lot of moisture there, especially over Texas, Arkansas, Missouri, Illinois. And it's taken its time moving, and it's because this dry mass of air that's behind it isn't really providing any input. So some hot temperatures and some evaporative processes going on there. And again, there's the Doppler radar. Cloud layer. 3.9 nanometers radiation map, by the way. And there is the water vapor map. That's today's meteorology segment. And we'll have to say goodbye to Twitch once again. Bye, Twitch. And let's continue on to bonus features here, since the daily space weather must go on. This bonus feature is from El Teide, Spain's ground-based solar observatory. I would note that there are significant filaments down here in the southern hemisphere and some in the northern hemisphere as well. The likelihood for coronal mass ejection remains, although has gone down a bit. And the sunspots have degraded a little bit also over the past 24. Next, I'd like to thank Smash Team for tuning into the videos, leaving comments, pressing share, pressing like, and pressing subscribe. Don't forget to tell your friends and foes about the channel. Lastly, thanks to our patrons, the true source of funding for the content. Thanks, patrons, for increasing the probability that these videos will continue to exist. We may have already quit doing this had it not been for you patrons. Please consider becoming a patron at patreon.com, as the goals of the channel are slowly being met, and look for major changes coming in the following months. Here's a colorized magnetogram of the local yellow dwarf. There's a close-up of Sunspot 2018, 2020, and 2021. Here's the intensitygram. So there's the colorized magnetogram. There's the intensitygram. And it looks like all of these sunspots have actually degraded a bit. There still is a significant possibility for solar flares. And again, I reiterate, additional coronal mass ejections. And we're expecting a coronal mass ejection strike again tomorrow. So here's some additional imagery for you here, folks. It's 304 angstroms with the SDO oriented way too far to the left. And that's about it. Thanks for tuning in. Remember, stare at the sun, attempt to understand the physics, don't drink it. If you do, don't drive. Thanks for leaving comments, John. And we'll see you next time here at Smash News Network, least busted name in news. And I would at least remind you to visit our own website, smashamash.com. Check our links, support our channel. Welcome to the Neo Renaissance, and may that solar wind be at your back.